Let's take a brief tour through the three waves of deep learning: a story of rise, fall, and resurgence. The first wave began in 1943 with McCulloch and Pete's mathematical model of a neuron. This early work inspired connectionist thinking networks of simple units mimicking brain function. In 1958, the perceptron showed machines could learn to classify data, sparking optimism. But in 1969, Minsky and Papert proved that simple perceptrons couldn't solve problems like XOR, leading to a sharp decline in neural network research. Still, important groundwork was laid. Backpropagation concepts emerged in the 60s, and Ivaknenko proposed multi-layer networks in 1965. Deep NNS were explored, but limited by weak computing power and inefficient training. The second wave emerged in the 1980s. Key breakthroughs included Fukushima's CNN for visual pattern recognition in 1980, Hopfield's RNN model in 1982, and Hinton's 1986 work making backpropagation practical. This enabled multilayer networks to be trained, and in 1989, CNNs were used to read handwritten digits. Sabenko's universal approximation theorem provided theoretical support. However, training deep networks was still hard. In 1991, vanishing gradients were identified, explaining why deeper networks failed to learn well. This, combined with the rise of statistical methods and support vector machines, caused another slowdown. Still, LSTM was introduced in 1997, which would become critical later. The third wave began in the 2000s, powered by better architectures, faster hardware, and more data. In 2006, deep belief networks proved that deep networks could be trained layer by layer. GPUs began being used for training in 2008, drastically reducing time. In 2009, Imagine a huge labeled image dataset was launched. Then came a game changer. In 2012, AlexNet, a deep CNN trained on GPUs, won the ImagineNet contest by a wide margin. Techniques like ReLU, dropout, and pooling helped make models more efficient and robust. From there, deep learning exploded. GAN's 2014 enabled realistic data generation. Deep reinforcement learning beat humans at games like Go. Architectures evolved fast. VGG stacked layers deeply. Inception widened networks. ResNet added skip connections to go deeper without vanishing gradients. Lightweight models like MobileNet made deep learning mobile-friendly. Object detection improved with YOLO and RCNN variants. GNNs gained popularity, extending neural networks to structured data. Finally, the transformer architecture led to a revolution in natural language processing. Large language models like ChatGPT, based on transformers, brought deep learning to the mainstream. From early neuron models to generative AI, deep learning has advanced through three powerful waves.
I think I'm falling for you.